So we're going to start solving some polynomial inequalities. Now, doing that is going to mean that we're going to need to remember how to factor, how to take our factors and find zeros, how to use those zeros to draw a basic sketch of the graph, and then use interval notation to find our answers. So we're going to start with a little bit of review, and this review is just about factoring. So always start by looking to see if you have a GCF. 4, 28, and 32 are all divisible by 4. So I'm going to go ahead and factor that 4 out. That leaves behind x squared minus 7x minus 8. Now this interior trinomial is divisible further or factorable further. We're trying to multiply to negative 8 and add up to negative 7. So that's going to be 4. Well, the only things that are going to multiply to 8 of any form and add to 7 are 8 and 1. We're going to go ahead and split our x squared. To make a negative 7, negative 8, positive 1, and there are our factors. All right. Second example, if I look across, this is a 4-term polynomial. I've got 3, 5, no GCF goes across all of it. However, I can look at just the first 2 terms, and they have an x squared in common, leaving behind 3x plus 5. Can look at the second 2 terms, they have a negative 4 in common, so leaving behind 3x plus 5. So my 2 parentheses sets are identical. So I can go ahead and factor that out. And what's left behind is x squared minus 4. Now, please don't just stop here. X squared minus 4 is a difference of perfect squares, so that can get further factored as x minus 2 and x plus 2. Now, the way that the order that you write those 3 factors does not matter in the slightest. It's all multiplication in the end, so if you've got a different order on your paper, it is all good. All right, last problem here. 3x cubed plus 17x squared plus 10x. So I want to look for a GCF, and while not the biggest GCF, or the best GCF in this particular problem, because I'm going to be stuck with that 3 in front, I can take out an x, leaving behind 3x squared plus 17x plus 10. Now, from this point, you can either do guess and check to factor this, or you can do the AC method. I'm going to go ahead and do the AC method as a quick reminder. So that x is going to stay in front. We're going to take our A value times our C value. So AC is equal to 30. So I want numbers that multiply to 30 and add up to 17. Well, I already know it's 15 times 2. 15 times 2 is 30. 15 plus 2 is 17. So that's going to get me 3x squared. Pick one of these 2 terms. It won't matter which one. I'm just going to go in order. So plus 15x plus 2x plus 10. And now I'm going to do the rest of this factoring like I just did the previous problem. All right, so I'm going to group the first 2 together. And for right now, I'm going to temporarily ignore this x. I'll get back to it, but for right now, I'm just going to ignore it. So that's going to be 3x, leaving behind, what would that be? X plus 5. We'll look at the next 2 terms. Those have a 2 in common, leaving behind x plus 5. Now, that x that I originally ignored, I'm going to go ahead and put all of this in a pair of brackets and then throw that x in front. X plus 5 here and x plus 5 here match, which is good. So I have the GCF of x, the common factor of x plus 5, and then 3x plus 2 left over. All right, so that's a little bit of a refresher on factoring. All right, let's actually get into using some of this factoring and figuring out how it's going to apply to some inequalities. All right, so we have this function over here, g of x. It's already in factored form, which is nice. And the first thing we're supposed to do is determine the zeros. Well, to determine the zeros, we're going to take each factor and set it equal to 0. All right, so 2x plus 1 equals 0. All right, so we've got a factor, a 0 of 0. Hold on a second. Yeah, a 0 of 0, a 0 of positive 5, and let's see, 2x is equal to negative 1, x is equal to negative a half. All right, so I have 3 zeros. I'm going to use those 3 zeros to mark my x axis. So I have 0, I've got positive 5, and this doesn't have to be perfect, so yes, it's ridiculous that I'm putting that over there, but that's okay. 3 zeros, this is a cubic function with a negative leading coefficient. So that means I'm going to start high, go through my x-intercepts, and end low. So the sketch of the graph would look something like that. Doesn't have to be perfect. This is just a sketch. Okay. Now, for part 3, it says, where is g of x? Well, this is our g of x function, less than 0. Well, less than 0 means it would be below the x-axis. So we've got this loop right here that's below the x-axis, and we have this part of the graph that's below the x-axis. So where is that? Well, it's from negative 1/2 to 0. Now be careful because I don't want x to equal 0. So I'm going to use parentheses here. So negative 1/2 to 0. And there's a second part to this, so I'm going to use what's called the union notation, it's a little u. Be careful. A capital U looks like this, so don't make it with a little tail on it. Yes, I know it's kind of specific. And then we're going to start going below the x-axis at 5, and that's going to continue until infinity. So that's going to be from 5 to infinity. So that's where g of x is less than 0. For question number 4, it says, where is g of x greater than 0? That would be above the x-axis. So above the x-axis would be here, and this little bubble of the graph. Okay, so if I look at that, now one other thing you can do that might help with the intervals, the x-axis, remember, is going to run from negative infinity on the left to positive infinity on the right. So that might help you actually write in the intervals. So this interval right here is going to start at negative infinity and go to negative 1/2. So that's the interval on the left. And let's see, that's going to be unioned with this part of the graph right here from 0 to 5. So 0 to 5. So that's the idea of what we're going to be working with solving these polynomial inequalities. If it is already factored, awesome. If it's not factored, that's what we're going to need to do. Okay. So let's go ahead and try example number 1 in the rest of this video, and then I'll pop up a second video to go through the rest of the problems. So first thing for problem number 5 says, solve the quadratic, then sketch a graph. All right, so let me zoom in on this. To solve this thing, I'm going to get one side of it equal to 0. So I'm going to subtract 12 from both sides. I'm looking at my GCF, and in this case, the GCF is 2. So I'm going to divide every single piece by 2. Now, you can do that with numeric parts. Do not do that division with a variable, okay? You'll lose one of your critical values, and that'll be a problem. I'm going to factor the polynomial on the left. So let's see, x minus 6, x plus 1. Let me double check. Negative 6 times 1. Yes, all right. So now I'm going to get my zeros. I'm going to take each factor, set it equal to 0, which remember is going to flip the signs. So x is equal to 6, x is equal to negative 1. Now I'm going to sketch a graph of this polynomial, this quadratic. And I'm going to use the two zeros I just found. So let's make x is equal to 6, x is equal to -1. And this particular leading a value is positive, so it's going to be concave up. It's going to look something like that. Okay. Along the x-axis, we've got negative infinity far left, positive infinity far right. That's just to help me with my intervals. Okay. So first thing for problem number 6 says determine when that function is greater than 0. So greater than 0 is going to be above the x-axis. So it's going to be here and here. And so if you read this from left to right, this is the shaded interval here. So from negative infinity, -1, and then from 6 to infinity. There's no equal to part here, so we don't want to actually use the zeros. So you're going to use parentheses there. So negative infinity to -1, unioned with 6 to infinity. And then for part 7, it asks determine when that function is less than or equal to 0. So less than, it's going to be under the x-axis, and equal to, you're actually going to use the x values, the zeros. So that means you're going to use brackets from -1 to 6. And you are going to include -1 and 6, so that's why you use the brackets there. All right, so I'm going to go ahead and stop the video here. Again, we're dealing with factoring, using the factors to find the zeros. From the zeros, we are drawing some x-intercepts, sketching the graph, and then determining are we above the x-axis or below the x-axis, or where are we for the actual inequality that we are given. So if you have any questions or concerns,